So can you see my screen? Yes, okay. So I will start with the isolated environments, and they solve some problems. For instance, when you want to install some specific version of the packages. You can also create a specific environment for each project. And then if two projects require different versions of the packages, then you won't see any conflict. So you can remove the environment and create a new one, and you won't see any error, right? So this is a way to install the different dependencies for all your projects without any conflict. So we saw previously that Conda works on an isolated environment. And here we will show how the PIP works, which is also a type of a virtual environment. So notice that at HPC2N, we only recommend to use a PIP. So there is always a situation where you need different versions of Python and also different versions of your packages. And the isolated environments offer you the possibility of dealing with these different combinations. For instance, maybe you have been using TensorFlow 1.x, and now you want the next version of TensorFlow. But you still need the old version of TensorFlow for another package. So this can be solved in an isolated environment where you can create separate workspaces for the different versions of Python. You can also activate and deactivate one of them at a time and work as if the other workspace doesn't exist. So there are different tools for creating isolated environments, and they have several things in common. And at HPC2N and UPPMAX, their workflow is as follows. So first of all, load the Python module, and then the site install package modules, which are required, and you can use this option. Then you create the isolated environment by using some procedure, for instance, VM, virtualenv, or Conda. After that, you can activate the environment and install or update the environment with the packages you need. Then work inside your isolated environment, and when you finish, you can deactivate the environment. Yes. So that you don't mix up the things. So some of the tools that are offered for creating isolated environments are VM, which is available both at HPC2N and UPPMAX. virtualenv is available also at both sites. And Conda, which is available at UPPMAX. And you can use that at HPC2N as well, but it's not recommended. So some comparison between VM and virtualenv. So they are almost completely interchangeable. And the difference could be that virtualenv supports older Python versions. And it has a few minor features, while VM is part of the standard library. So a few key points regarding virtual environment. So you can tailor an environment to specific versions of a Python related packages, not interfering with other installed Python versions and packages. You can make one for each project in order to have the reproducibility of your results. You can also add the specific versions, right? So that you know what versions you did at some research project, for instance, you get the same results. So these are the tools for creating the virtual environments that we saw before. So how to create a virtual environment with the VM or virtualenv. So at UPPMAX, you can follow these guidelines. First, load the Python module, and then create the virtualenv environment with this command here, and adding the options for the site packages. And this will be the name of the environment. And here is the way to create a virtual environment with vend. So load the Python module again, and then use this command here to create the virtual environment called example in this case. So in the case of HPC2N, procedure is similar. First load the Python module and the prerequisites, in this case, the GCC compiler, and then run the virtualenv plus these options for the system side packages and the name of the environment. And the VM way is similar, the Python modules and the line for creating the virtual environment with Python -m and VM. So if you add these flag system side packages, it will include the packages that are already installed in the loaded Python module. So here there are some notes when you are installing the environment. And then we can proceed to activate the environment. So at HPC2N, so we first create the environment with virtualenv. And in this case, I am using the path to the project directory, yes, for the present course. And here at this location, right, you can create your own folder with your username and then the name of the environment. In this case is example. And this can save some disk space, because if you create the environment in the home directory, then you can easily exceed the quota, which is about 25 gigabytes for your home directory at HPC2N. So that's why you are encouraged to create your environments in your project directory, which would have more disk space. And once you create the environment, you can activate it with the command source and the location of the environment and these two additional suffixes, bin and activate. So I can show you briefly how it works. So can you see my terminal? Yes, okay. So then the first thing that I need to do is to load the Python version and the dependencies. So notice here that I'm using the 3.9.5 plus some additional modules. Okay, I loaded that. And then notice that I am in the folder for a project, yes, which is located in the Proin no backup folder. And then I added my folder with my username here. So then I can create a virtual environment at this step. Okay, and if I do ls, then I can see that there is a folder that is called example, and I can take a look at the content of this folder, and it contains two additional folders, bin and lib, plus some configuration. So, and here I have created the environment example, and I can activate it with the command source and then the path to the active script. So this is something that I haven't found it easily, and it's how to see what environment is active when you use virtualenv. So then to know which environment is active, you can echo the virtualenv environment variable. So, and this will tell you that this environment is active at this moment. So there is a note regarding the source command. So it can be replaced by dot, like in dot example being active. So PIP. So this is a way to install your packages. We saw before that you can do that with Conda as well. This is another way to install the packages with the specific versions that you need for some Python version. So how it works, you type pip installed plus these two recommended flags, no cache dir and no build isolation. And then the name of the packages. And if you want, you can list the specific versions that you need. Yes, for reproducibility purposes, for instance. Then you can deactivate your environment where you don't need it. Here there is some explanation of the previously mentioned flags. So no cache dir is required to avoid it from reusing earlier installations from the same user in a different environment. So PIP caches the already installed packages. So, and later on, in order to avoid some downloading time, for instance, one of the reasons could be that. So PIP tries to fetch the installed versions, right? Rather than installing it again. So the no build in isolation is useful when you are building, for instance, a Cython library. And in this case, it will use the loading modules from the module system. So now let me go to this example here. And we will install some packages as a simple example. In this case will be the package called Spacey. So first of all, we will load the modules. I did it already. And then we can activate the environment as I did also already with the virtualenv key. And then you source the environment and you can start installing the packages. So in this case, I will do it with the PIP install. Spicy. Yeah.
It should be Spacey with A, I think.
Yeah, that's correct. It seems that it installed a package called Spicy. Mm-hmm. So be careful about this. Let me see. Spacey. Okay.
Yes.
Now it's
you could do pip install several times. So now you have both Spacey and Spicy, and then you can continue and extend your virtual environment for how long as you want to. I mean, yeah. Adding some packages that you recognize that, okay, I need this one as well. So you don't have to do it only once in one line, but you can do it several times.
Yeah. You can also do that with additional packages, as Björn mentioned. And here we can try another one. For instance, Seaborn, right?
Excuse me, I have a question.
Yes.
If I have installed Conda now, should I deinstall Conda somehow before doing virtual environment, or can they live together?
You should unload your Conda module. And if you had an active Conda environment before, you should deactivate it. And
Okay,
then,
it's not active, but okay. So okay.
And then you unload your Conda module as well. Because when you do this virtual environment, you have to load a Python module, and that you can't do when you have Conda module active. Basically.
Okay. And in the exercises, will we continue with Conda or with the virtual environment?
It's a virtual environment now, so please turn off your Conda. We should have mentioned this.
Mm-hmm.
Okay.
Yeah, that's true. That's true.
Thanks.
So do you want to take this part, Björn, using install packages in Python?
You can continue if you want to.
Okay. Okay, so we have seen how to install the packages by using PAP, and these are packages that you self-install, right? So now we will see how to use the packages that you install on your own. So we saw how to install the Spacey packages, right? And here I can start a new terminal. Okay. Then I can activate my environment. And then I start a Python session. And here I start working with the packages the package that I installed, Spacey. Interesting. Okay, so it seems that the package is installed, but there are some issues. So Spacey is installed, right? But there are some issues with this package which are not related to the installation. But essentially, what you do is that you start your Python session or your Python code, and then import the package as usual. So with this command, you can list the packages that you already installed. And I show you that previously, but for all the packages, and this will be for the user installed packages. Interesting.
If you scroll down a little, you see that you can use --local as well to see what is just in your environment.
Yeah, that's true. Okay. You want to take this part, Björn? So that I can take some.
Yes, I
Okay.
can continue.
Yeah.
Okay, yes. So, yes. So you can install from text files like you did from in Conda as well. So these requirements text, they could look like this. So they just know the packages that are needed. These are not pinned to specific versions, but you could also pin with versions. And note here that you need these double equal signs. So in the Conda environment, where you use this environment.yaml files, then it was just one equal sign, but here you have to use double. So this R means that you install from this file. You can also create this requirements file by pip freeze. And that will also include all the system site packages if you included them with the system site packages option. But if you only want to list the packages specific for the virtual environment that you actually by hand install in this environment, then use this --local as Pedro showed before. So if you want to create a file just from the local environment, you use this. So this is a good way to spread your working environment to colleagues, like I said for Conda. So this is one way to collaborate, basically. More about dependencies in this course, Python for scientific computing. You could also use something called pyenv. That's another method to work with isolated environments. But basically you can probably work with Conda instead. But if you are working on HPC2N and need some other tool compared to the ordinary virtual environment, maybe pyenv could be something for you. The thing here is that you can install your own Python version because the virtualenv or venv, these are based on the Python that you already have. So if you have loaded Python 368 or 395, that will matter for the virtual environment. Yes. So we will not cover this. This is just some warning about Jupyter Lab or notebook in a virtual environment. And I won't go through this, so please check this if you know that you will work with Jupyter within a virtual environment. And here is some summary of the workflow that you could go back to after the course. For some reason. And did we have a question from Samir?
Björn, like, could you please explain a little more on the local, like how does, like, if we are going to give this pip install the packages and if you're going to give -local, what is the difference actually? Like locals.
Local, basically. So if you did this, pip install and then numpy matplotlib, then only these two will be local. So if you do a pip list local, then only these two should show up, I think. Whereas if you do a pip list without list local, it will also list the ones that you inherited from your Python module. So this list will be very much longer. Yes.
Thank you.
Yes.
Thank you.
Yeah, so if you share your Python project with another user on the same system, then you can say that use the requirements from this pip list local, but also use system side packages, because then you will get same packages that I had when using the UPPMAX system, for instance. But if you will share your project with the user outside, for instance, UPPMAX, then you may have to be sure what all the packages are to be needed. So in this case, it might be better to just skip these system side packages and then just make all your packages local. So then you really see what is needed for this project to work on any platform, basically. So there is an extra reading session about developing in isolated environments. So that is when you are developing an own tool or program in Python, and what you can think about then. So how to define what dependencies you need and how to share this information for your potential users of your software. We are a little bit after the schedule, so I hope we will have some time for the exercises in the afternoon. Instead, I will leave the floor for the batch mode. So